All right, one and all, good afternoon. Thanks very much for coming along today. Another super popular webinar. Last time I looked, about 575 registrations, so always a pleasure, and always a pleasure to be with the esteemed company of my colleague Peter Worth. How are you, Peter?
Good, thank you. Afternoon, everyone.
Very good. For Peter, for those who aren't familiar with Peter, he is our Queensland specification manager, an all-around nice guy at Ocean Protect. But look, just before we kick off official proceedings, just a reminder, this is, I think, gee whiz, I think it might be number 8 of the Stormwater Fundamental series. Super popular. I think we've had many thousand already. I think we're generally getting about 650, 700 regos at most of them. So super stoked to have all the support from various industry professionals around Australia and also overseas. I saw quite a few registrations over from overseas in the list today, so welcome. And just for a reminder, if you want to find out more, if you hadn't registered for the remaining 4, please jump on the Ocean Protect website, .com.au/webinars, where you can find out about the remaining 4 and also get recordings and the slides of all our previous webinars as well. And also, if you want to keep up to date with new announcements and new webinars coming up, best to subscribe to that newsletter. We'll probably in the next couple of months announce what's going on for the Fundamental series in 2025, so stay tuned for that. But look, first up, before we dive into the content around proprietary storm treatment assets, full disclosure, we've got obviously a significant conflict of interest here. Ocean Protect, both Peter and I work for, we sell proprietary storm treatment assets, a whole range. And look, we're trying to mitigate those conflicts of interest as best we can. We'll try and provide full references to everything we say today. But obviously, happy to take questions from the field as well. And just a reminder, folks, if you do have any questions, please put them in the Q&A panel. So generally, case to first in, best dressed. So if you have a question you'd like Peter and I to try and answer, please put it in the Q&A panel. And just a reminder also that today's recording and the slides from today will all be made available at that website. Probably just gives a couple of days, sorry. And if you do have a CPD request form, and we do get several, please email them through to that email address there, inquiries@oceanprotect.com.au. Cool. So let's just dive straight into it. So what we're going to talk about today is obviously proprietary stormwater treatment assets. I'm going to talk very quickly about what they actually are. And Peter's going to give an overview of just some of the Ocean Protect proprietary assets, just to give you some sort of insight as to, I guess, some of them. And also, I'm going to dive into some busting of some common claims around proprietary storm treatment assets. So that's where it might get a little bit controversial, which we always love. So be sure to hang around for that. But I guess first up, why are we even asking this? Why are we even covering this topic as part of a Stormwater Fundamental series? I guess fundamentally, proprietary stormwater treatment assets are a fundamental part of our industry. So Ocean Protect is just one supplier of proprietary stormwater treatment assets in Australia. And just ourselves, we've installed over 66,000 over our 21-year in operations. And we reckon, based on some estimations, and it's not super accurate, but it's the best we can do given that we've got so many assets all around the country, we probably stop about 10 tons of pollution from entering Australian waterways every day, 10 tons a day. And to date, we've probably stopped about 20,000 tons of pollution. And you'll see some photos of the pollution we stop. It's pretty manky stuff that you do not want to be swimming in or whatever. So, and we're just one supplier, albeit we're the coolest, clearly, but we're just one. So yeah, it's important. So first up, what are they? What are proprietary storm treatment assets? Bizarrely, I actually couldn't find a definition. I've looked through a whole bunch of guidelines from Blacktown to Melbourne Water to Storm Australia. I can't find a definition, which is bizarre. So subsequently, I've actually tried to come up with my own definition, which is on the screen. I'm not saying it's absolutely, Oxford Dictionary worthy, but it's a start. So basically, stormwater treatment assets are assets that are put into, I guess, treat stormwater, but they generally include multiple proprietary or manufactured components that essentially can only be readily supplied by a single supplier. And Peter will give you some insight into other some of our proprietary assets, but that's sort of my crack at a definition. Okay, so we've got a range of proprietary assets. So generally non-proprietary assets are the stuff like wetlands, bioretention swales, where you can get the plants and the, I don't know, the mulch, etc., from multiple suppliers. Cool. So I'm going to handball it now to my esteemed colleague Peter, who's going to run through some of our Ocean Guard, storm filter, and jellyfish, starting with the Ocean Guard. Peter, over to you.
Hi guys. So starting with the Ocean Guard is our gully pit insert gross pollutant trap. Basically, it's a mounted into the pit type system, sits below the grate. There's diverters, flow diverters at the top of the system that sends the flow into the basket. We typically have a 200 micron media bag inside the Ocean Guards. There's a high flow bypass slots at the top there as well for when the flow rate exceeds 20 liters a second, which is a treatment flow rate per Ocean Guard. And we have different bags and different depths and different sizes that we can use to fit generally most standard size precast concrete or plastic pits that you have on your projects. The picture on the screen there is showing some Ocean Guards installed, capturing a lot of gross pollutants and some pretty manky stuff. So they do a great job of pre-treating before our other treatment assets that we're going to talk about as the slides go on. As I mentioned, they fit in generally pretty standard size pits from 450 by 450 up to 1200 by 1200. As you can see on the screen there, you can sit them below the grate. You can have piped inlet as well. Just keep in mind if you are doing a piped inlet above an Ocean Guard in a pit that you don't want to set the Ocean Guard too deep. The Ocean Guards have plenty of real world published studies and data on them, 2 peer-reviewed reports, and it is also SCUDEP verified, the Ocean Guard pit basket. Maintenance is fairly simple. You need to lift the grate and remove the bag. Basically, there's a ring around the top of the bag, so you can remove the bag and empty out the contents, give it a quick backwash and put them back in. We do have replacement bags available too if they're damaged. So just let us know if you've got a site that has some damaged bags, we can always replace those bags. It's a fairly cost-effective way of fixing them up if there is some issues with the bags. And we've installed over 20,000 throughout Australia to date. See them in a lot of jobs. We always pretty much use them for pre-treatment in front of our tertiary filtration devices, which I think we're going to talk about next. Happy to do music modeling. As a lot of you attending will probably be aware, we can do that free of charge. So if you have any projects, feel free to send them through to us as well. But yeah, the Ocean Guard is a very commonly used product when we are doing music models as a pre-treatment device.
Cool. We can dive straight into the storm filter now, Pete, if you like.
Yep.
Let's do it.
The storm filter cartridge we've sold in Australia for 25 plus years. Numerous systems already installed and looking at them every day. It's a very flexible system, so it's a media filled cartridge. You can have multiple different configurations for the storm filter system. We can use them as in a precast unit for treatment only, or if you do have a detention requirement on your site, we can also put them in a section of your larger detention tank, usually at the inlet. So we treat the first flushes and the early flows off your site. Basically, it's a media-filled cartridge with a float inside, siphon actuated. As water builds up in the chamber, it lifts that float and draws the water radially around the full surface area of the storm filter cartridge down through the center tube and out through the underdrain pipework that we encase in a false floor within the chamber, as you can see on the video on screen. Very efficient for removing your TSS, TP, and TN, and again, SCUDEP approved for the piezo media. Commonly used in many commercial, industrial, and residential areas, and other projects like roads and airports. We've installed thousands of these throughout Australia to date. We have 3 different hydraulic height cartridges available: the tall 690, the standard 460, and the short 310 cartridge. Just to note, however, the standard 460 and the short 310 cartridge are physically the same height. The float inside the cartridge is different, so it actuates that siphon and backwash and engages the treatment at a different head. All right, so just keep that in mind if you are looking at a shallow tank. Typically for the tall 690 cartridges, we'd request a minimum internal tank height of 11 to 1200 mil. For the standard and the short cartridges, 800 mil is about as low as you want to go for those type of systems. As I mentioned before, the Stormfilter piezo media is SquidApp verified and approved, so we can use that in any areas that you may need to fit that bill, or councils that have SquidApp requirements. And there's plenty of real world studies and peer reviews available. If you want the data, just let us know.
Cool.
As you can see on the screen, they do a great job of capturing a lot of the pollutants that are in the stormwater runoff. We do the maintenance of the storm filter systems a little bit, for lack of a better analogy that I'm yet to come up with, a bit like a swap and go with your gas bottles at the service station. So basically, if we had a system that had 10 storm filter cartridges in it, and we knew that it was time to change those cartridges, which is typically anywhere between 1 to 3 years, we would come to site with refurbished cartridges with new media. We would take out the old cartridges and replace them with the new ones and clean out the chamber at the same time. The other advantage to the storm filter cartridge, which is a bit different to some of the other products on the market, is that we can undo the cap at the top, lift the hood off, and remove the media via a suction hose, which allows you to pass the cartridges out empty, which can be a good thing to keep in mind if you've got shallow tanks and tricky sites. To date, we've had over 31,000 installed throughout Australia, and there's over 250,000 installed overseas. In my opinion, it's the most used proprietary filtration product worldwide. Again, happy to look at music models and assist you guys in appropriately sizing your treatment trains or your storm filters and ocean guard systems for your projects.
Cool. Let's dive into the jellyfish, last but not least.
Okay, the jellyfish is a little bit different to the storm filter cartridge, where we build basically water inside the chamber to actuate the siphons in the storm filter cartridges. It operates a little different. You've got an inlet pipe, noting that all jellyfish systems need to be offline. Inlet pipe, water comes in, hits the maintenance access wall. It's not a weir. That is for ongoing maintenance. Forces water down into the sump. Water then has to basically change direction and float up, which promotes sediment dropping to the ground, and goes from the outside through the tentacles and up through a hollow center tube inside each of those tentacles and the jellyfish cartridges. We also have a plastic separation skirt around the full depth of those jellyfish cartridges to help stop some of the oily stuff which you might get on car parks and sites like that from adhering to the membrane of the jellyfish cartridges. Water basically flows up through the top and out through the outlet pipe. Typically, you need 460 mil upstream driving head for a jellyfish system. Again, very suitable for commercial, industrial, residential projects. And it's very popular for sites that require a low driving head for one reason or another. If you've got hydraulic issues, installed many jellyfish systems across Australia to date. Offline configuration, as I mentioned, you can do that a couple of ways. Basically, you can have a weir and an upstream pit that sends the low flows to the jellyfish system off your main trunk line. If you don't want to use a weir, you can lift the bypass pipe to create a hydraulic weir. Again, the typical driving head for a jellyfish system is 460 mils, meaning that the high flow bypass pipe would be 460 mil higher than the outlet of that offline jellyfish system. Typically, there's 150 mil between your inlet and your outlet pipes of the offline jellyfish. The image on the right-hand side there is just the different size jellyfish systems from the Jellyfish 1200 1-1, which is one of the smallest units that we currently make, and up to the Jellyfish 3250 28-5, and all sizes in between. 2 real-world published studies, 2 peer review reports, and again, SquidApp verified and approved by Stormwater Australia, so able to be used in any sites that you might need to, or LGAs that require that SquidApp approval.
Yeah, we talk about SquidApp approval, but it's probably worth noting that it's only required in a few councils in southeast Queensland currently, and I think Western Sydney, whereas outside of those areas, including those areas, pretty much OceanGuard, Stormfilter and Jellyfish are pretty much approved in the vast majority of councils, at least for private sites. But if you're ever in doubt, obviously you can just contact us and we'll
reach out, let us know. We have minor servicing, which is rinsing of the jellyfish tentacles, and a major service, which would require replacement of the tentacles in the jellyfish systems. Replacement of cartridges usually 2 to 5 years. Rinsing, we normally say 6 to 12 months, depending on the site. Every site has different pollutant loads, so it's always good to inspect them initially to see what sort of loads you're getting off your site, and then establish an ongoing maintenance regime, which we can do for you as well. Ocean Protect offers maintenance of all our systems. Over 1,600 jellyfish systems installed throughout Australia since 2017. And again, happy to assist engineers or councils or whoever in appropriately sizing our jellyfish systems and all our systems for that matter.
Cool. That's jellyfish. Thank you, Peter. And if you've got any specific questions about those specific assets, feel free to just put them in the Q&A. But I'm gonna dive into something a little bit more controversial and sort of talk about some of the common claims I've seen in our industry for several years around proprietary assets. And these are generally the main ones I see. And it's obviously relevant for Ocean Protect assets, but it might be sort of relevant for, I guess, other manufacturers as well. But I guess it's worth pointing out that I'm going to have to, just to avoid any dramas with any other companies, I'm just going to predominantly focus on Ocean Protect assets as the example when I'm sort of talking about some of these claims. So claim number one is that, look, if, for example, if Ocean Protect went belly up, we won't be able to get any of the parts or components, so the assets themselves will be useful. So Stormfilter, for example, yeah, the media's used up, absorbed all the pollution. Ocean Protect for some reason went belly up, can't get replacement media, so the Stormfilter cartridge is useless. Is that right? Yeah, I've heard this commonly. Look, I think a couple of points on this. So number one, Ocean Protect is at extremely low risk of going belly up or bankrupt or otherwise into liquidation or whatever you want to call it, or closing up shop. We've been operating for over 21 years in Australia now, and with that, sharing our bank details, we're in a very financially sound position. So extremely low risk of going belly up. Okay, but for whatever reason, if we did, Contech, which is our partner company in the US, they're a very, very financially sound company. I think they've got over 1,600 employees or thereabouts, been operating for longer than Ocean Protect. And so if Ocean Protect weren't around, you could easily, or anyone could easily get the components or parts from Contech directly. But having said that, if Ocean Protect wasn't around, I'm sure, given the nature of our business, someone would probably take our spot quite quickly, recognizing that it is a financially sound company, and it's doing a great job as protecting the environment and making a dollar at the same time. So it's a pretty cool business, I think. So I think if Ocean Protect went around, someone would take our spot, albeit not as cool, but they'd probably give it a crack. Am I wrong, Peter?
No, you're right.
So look, this claim totally busted. I just don't see this as accurate in any way, shape, or form. Number two, The claim that non-proprietary assets like bioretention or wetlands are much less likely to fail, i.e., like they're not going to work or whatever, if they're not maintained relative to proprietary assets. So the general comment I get is, oh, I can leave bioretention alone for years, decades, and it'll still work. No worries at all. Whereas ocean protect assets or others, yeah, if I don't maintain them, they won't work. Okay, look, let's have a look at the data around this. So I'm going to show a couple of studies. So first up, this is a study, full disclosure, I was co-author on this study, but we basically collected condition assessment data for bioretention systems. One set of data from Moreton Bay Regional Council. I think by memory, there's about 380 bioretention systems. And another council in Southeast Queensland, which I can't name, they owned a whole bunch of bioretention systems. And long story short, about 20% were in a poor or very poor condition, which basically means they need to be rectified, i.e. kind of major rectification works like replacing the system. And I'm recognizing I'm quoting myself and my co-authors there, but straight out of the paper there, which was published at the Auswater Conference, a lack of maintenance activities is predicted to be the key reason for the poor or very poor condition assessment ratings. So that's just bioretention. Recognizing it's just one study. Another study, if I can refer to, it's by Andrew Thomas, who's now president of Stormwater New South Wales. And I think I can see Murray Powell's name there. He's vice president of Stormwater New South Wales, and Tim Fletcher and a couple others. They looked at condition assessment ratings for a bunch of assets, bioretention systems, wetlands, etc., and obviously found a very significant proportion were in poor condition. And again, I'm quoting this paper here, maintenance activities or the lack thereof is the leading reason for the high proportion of assets being in poor condition. And again, they say here, appropriate levels of maintenance may be the single most important issue currently facing their effective performance. So again, this idea that you can leave non-proprietary assets without any maintenance, I just don't think that the data is there to support it. I was talking to a consultant yesterday even, I won't mention their name, that he thought the failure rates were probably closer to about 80% for bioretention systems. But look, whether it's 80 or 20 or somewhere in between, fundamentally, these assets, bioretention, wetlands, et cetera, need to be maintained, just like all assets, including proprietary assets. So we know that our assets capture pollution. So this is a before and after photo inside a storm filter cartridge. So that's the media on the left, which is the P-Sorb media, brand new, ready to be put in the ground. And the photo on the right is after it's basically been in operation for probably a couple of years or so. Absorbed a whole bunch of pollution. We know that this media needs to be replaced after a certain period of time. And that that's actually reasonably easily done, as Peter referred to. And like we see what our assets do, and this sort of pollution will also accumulate in other sort of filters, whether it's a vegetated system or a wetland or whatever. I'd really question the ability of, say, a bioretention system to just sort of sit there and receive stormwater flow, intercept this sort of pollution, and not need this material to be, routinely, albeit infrequently, cleaned out. It's not going to go anywhere, that's for sure. Give you an example. This is a storm filter, shopping centre car park in Adelaide. Pretty disgusting. Again, if bioretention is a filter, it hasn't got it needs to be maintained essentially. And this is just our crew doing some maintenance. This is replacing sucking out the filter media, and that we can just, as Peter referred to before, just basically replace old filters with new filters quite easily. Again, that's another photo of new filters on the left, old filters on the right, very easily replaced. This is jellyfish Peter referred to before. These are new cartridges, but you kind of see these are old cartridges been in the ground for a few years. You can kind of see what they collect. Again, all assets, all stormwater treatment assets need to be maintained. I don't think it's appropriate to say non-proprietary don't need maintenance, or even they need less maintenance than a proprietary asset.
One thing to probably mention too, Brad, sorry to interrupt, is it's always paramount that we don't have our proprietary systems, I'll just speak about those, online before construction is finished on site. So these systems are designed via music models and stormwater management plans for the end use of the project. So we don't want them used as, construction load type treatment systems.
Cool. Thanks, Peter. I'm not sure if you guys can see this. It doesn't appear very well. It's hard to take photos on underground, but this is a storm filter. Sorry, this chamber with a whole bunch of storm filter cartridges underground. And our esteemed director Michael Wicks checked this out 20 years after they were installed, and we don't believe they've ever been maintained. And look, fundamentally, it's really easy to get this back up to speed. So had a whole bunch of accumulated pollution. The cartridges had probably been hit their limit in terms of accumulation of pollution. But yeah, pretty easy to fix up. Just suck out the sludge at the bottom and replace the carts as we've referred to already. So one thing I would say is with at least the storm filter, it's very easy to bring it back online if it hasn't been maintained for a very, very long time. Even if it's just I've seen ones where an oil tanker has just dumped a whole bunch of oil or whatever in it, and it's a reasonably easy thing to rectify or fix up and get back to speed. Certainly relative to a bioretention system or a wetland. So this claim that the non-proprietary assets are less likely to fail, I just don't see the evidence to support that at all. Happy to be disagreed with, and I know I've got a conflict of interest, but I'm happy to look at anyone's data that can show or somehow indicate otherwise. Claim number 3, non-proprietary assets are cheaper to maintain. Apparently, Peter, I'm not sure about you, apparently I'm high maintenance, as are proprietary assets. Please, come on. No, I'm kidding. To talk to this point, we actually did a study a couple of years ago. This is publicly available in that review paper you can see on the left there. We looked at a typical residential development in Brisbane designed to achieve the state planning policy targets, which is required by council. And we looked at how much it would cost, whether it's a conventional bioretention or a wetland or an ocean protect Filterra bioretention system or a storm filter or a jellyfish combination. What's going to be the cheapest, both in terms of construction costs or acquisition costs and maintenance costs. And we've got a very good understanding of how much our assets cost to install and maintain, because we quote on it every day, literally. And for the cost data, we use Melbourne Water information, which I'm not sure how accurate it is, but it's probably the best industry available information I could get my hand on at the time. And it's worth noting that we exclude any benefits associated with land cost savings. Obviously, proprietary assets, when they're underground, they can save a lot of money with not using land, but we've completely excluded that from the analysis. Just to show you the results, again, it's all publicly available in that report I showed too. This is the acquisition costs for those various scenarios. So you can see here a scenario of jellyfish with Ocean Guard, storm filter with Ocean Guard, et cetera, relative to typical bioretention, whether it's on-street rain garden or tree pit or bioretention system or a conventional wetland. And again, these are all sized to achieve the pollutant load removal targets as per state planning policy for that Brisbane residential development, with both high cost estimates and typical cost estimates. So generally, in this case, wetlands are pretty expensive. Filterra tree pits would be the most expensive to install. The Filterra bioretention is typically cheapest for this scenario. This is consistent with what we see day in, day out. But in terms of maintenance costs, a typical bioretention system is probably the cheapest if you believe the Melbourne Water costs, which we will for the time being. But certainly the proprietary assets are not significantly more expensive. The wetland option is actually more expensive than some of their proprietary solutions. So that sort of indicates to me that, yeah, not always is proprietary going to be more expensive to maintain. In fact, sometimes it can be cheaper. Certainly the conventional bioretention tree pit solution in this case would be the most expensive. But that study aside, we've actually looked at, back in 2022, a couple of years ago, we looked at, okay, how much does it cost to maintain our own assets on the Gold Coast? So we've got at the time we had 12 facility management plans and 48 maintenance contracts. So FMPs, for those who aren't familiar, it's basically like it provides, Ocean Protect basically look after the stormwater treatment assets. So it provides full warranty and insurance for the life of the contract, which can be, a year or so, up to 15 years, I think, on the Gold Coast.
25 years is
25
typically
years.
the
I'm not sure
longest we do.
Yeah, we've seen 25 years in Western Sydney. I'm not sure about on the Gold Coast, but certainly it's long-term contracts often. And we can't, this cost is a fixed sum. So we've got to be confident that it's, reasonable. But just to show you what the study, the results showed. So this is the annual fee per year per site for all our contracts, for FMP contracts and maintenance contracts across the Gold Coast. But if you want to break that down into a cost per dwelling, that kind of what that box plot shows essentially the spread of data. But long story short, if you look at just the residential sites for the FMPs, to look after essentially all your stormwater pollution problems. So Ocean Protect are charging roughly an average of $2.65 per dwelling per week for FMPs. And for the maintenance contracts, it's about $5.43 per dwelling per week. Long story short, it's for an FMP, it's about the cost of half a cup of coffee per week per dwelling. For a maintenance contract, it's about a cup of coffee per dwelling per week to perform a really fundamental job of protecting the downstream waterways, in this case on the Gold Coast. I think I wouldn't have thought that would be overly expensive. I haven't done that comparison for bioretention system maintenance contracts because that information is often it is not readily available. But I don't think that's super expensive. I'm happy to be disagreed with, or if someone has other evidence to indicate somehow that this is somehow expensive, or bioretention or wetlands are way more cheaper. I'm happy to talk to that as well. But it's also worthwhile noting on maintenance as well, like the cost information that we use is if Ocean Protect do the maintenance. As we sort of indicated, our assets can be maintained by others. Obviously, you still need to get the parts and components from Ocean Protect within Australia, but certainly the other maintenance activities, whether it's cleaning out a gully basket or sucking out a tank, certainly can be done by others. Okay, and all the guidance around how to do that is readily available. So whether it's the Stormwater New South Wales guidelines put out a few years ago by Stormwater New South Wales, led by the legendary Murray Powell from Optimal Stormwater, or whether it's one of our publicly available maintenance guidelines. Maintenance can certainly be done by others. So the claim that non-proprietary assets are less expensive, look, it is plausible. But I think as a general rule, I don't think it's fact that non-proprietary assets are always cheaper. It's a horses for courses. It's very site specific. And if in doubt, feel free to reach out to us and get a quotation and compare it to other devices.
Yeah, happy to provide the info for site specific jobs. Just let us know.
Cool. And as I've sort of indicated before, all assets need maintenance. And as I've indicated, the preferred solutions and the associated costs are very site specific. And I reckon all our decisions around what's the best solution for a particular site should be informed by appropriate life cycle cost analyses, not just a blanket rule that, no, proprietary assets are more expensive, which, as we've indicated, I don't believe is true at all. Claim number 4, non-proprietary assets provide other benefits that just proprietary assets just don't do, whether it's amenity, cooling, habitat, hydrology. Okay, let's look at that. So, and I spent years, 15 years or so, putting in non-proprietary assets, wetlands.
Before you saw the light.
Wetlands, these aren't all mine, some of them certainly are. Bioretention systems, yeah, I'd be the first to admit these look good. They'll provide passive cooling, amenity benefits, etc. Docklands, these are tree pit bioretention systems. But obviously, we've all seen photos where, the asset isn't, the bioretention or the wetland is certainly doing nothing to improve site amenity, to be nice about it. So whether it's a bioretention system that looks bloody awful in Hobart, got a dirty great big fence around it, it's deep, it's ugly, etc. I've got lots of photos of this. I'll charge through them. Obviously, some sort of bioretention system there in the car park in Ipswich, not looking too crash hot. There's lots of these at a certain location in Brisbane, without mentioning names. And this is actually just last week. I checked out one of my old bioretention systems that I put in at the old Woodlands development. Disappointingly, it's not looking too crash hot would be the fair description. This looked really good. I'll in my defense, or in the defense of everyone involved, when I last saw it. But gee whiz, it was disappointing. I think someone's, got a fire pit in the middle of it because, what else you do with a barren area of land, I guess, in this area. But yeah, this is supposed to be a bioretention system. So certainly not adding much in the way of amenity. As per these ones, retaining walls everywhere, it looks ugly, terrible solution. And we see this time and time again without mentioning any names like Bunnings or McDonald's. Oh, sorry. Anyway, moving on. And then you got public safety hazards. Like this one, for example, in Toowoomba, they've got a railing there to protect your, your shopping trolley from going in, but it's at a perfect height to trip. And then by the time your head has reached terminal velocity, it's probably going to meet with the concrete edge. And we joke about this sort of stuff, but it's a real risk. I fundamentally, I think a lot of the time we should be going underground because of the site constraints. Having said that, sometimes people put bioretention systems underground, as per this one on the Gold Coast. This is a bioretention system that is basically underground. I've got a grate over the top of it, I guess, to let a bit of sunlight in. I mean, if someone can convince me this is water sensitive urban design, I would love to hear from you. But again, if you've got a council that has a blanket rule of, non-proprietary assets have to be put in time and time again, and Peter and me see this every day, this is often the result. I think
just not always the best solution for every job.
Exactly. And look, so sometimes it's a lot easier just to go underground where your site is constrained, where you can install the assets, maintain them appropriately. This is a before and after photo. You don't always have to have a car park or a road above it. It could be used for landscaping, etc. And then you can easily access it to maintain it, clean the pollution out without any public safety dramas. So this claim, look, I'd be first to admit sometimes bioretention and particularly wetlands can add a lot of site amenity and cooling and habitat values, but not always. So again, we should be developing a solution specifically optimized for the site constraints. Would be a fair comment. This is the last one I'm going to cover. Non-proprietary assets are just better at removing nutrients, particularly dissolved nutrients. Without mentioning names like Mid Coast Council, this is their rule. This is the reason why they don't allow proprietary assets. Sorry, folks at Mid Coast Council and others, the data just doesn't prove that at all. In fact, the opposite is probably true. So these are a bunch of studies looking at real-world performance monitoring data for conventional bioretention systems, looking at their ER's efficiency ratio, which is a concentration reduction metric. And you've got TSS, so total suspended solids, total phosphorus, dissolved phosphorus, total nitrogen, oxidized nitrogen, ammonium nitrogen, dissolved inorganic nitrogen, and a bunch of studies. I can provide the full references if people want, but they're all readily available. And long story short, conventional bioretention performance is highly variable. So yeah, sometimes it can do a good job at removing pollution, particularly TSS. But often we see nutrient concentrations increasing across the asset. If I look at proprietary assets, and this is a compilation of published real-world studies of Ocean Protect proprietary assets, including Filterra bioretention. Filterra is always in a weird space. The only proprietary component is the filter media, which obviously sometimes conventional media has proprietary media, but I've grouped Filterra into this bunch as well. But long story short, the published studies that we have available, and that's not just, authored by Ocean Protect guys, it's from overseas and others, etc. And other authors within Australia, generally really good removal rates of TSS, nutrients, etc. Particularly storm filtered jellyfish Filterra, consistently high rates of nutrient removal. Certainly far more consistently high than relative to conventional bioretention systems. So yeah, and look, if in doubt, there's more data. International Stormwater BMP database. I'll charge through this because I think I talked about it last time. This is publicly available. This compiles a whole bunch of data from all around the world. Around the performance of individual assets. So in this case, you've got, I think BR is conventional bioretention. HRMF is high rate media filtration. HRBF is high rate biofiltration. So HRBF is like Filterra. HRMF is like storm filter cartridges. So this is total nitrogen. Yeah, both do a pretty good job of removing total nitrogen. Bio is good for ammonia nitrogen. But if you look at NOx, not both devices, conventional bio and HRMF, like storm filters, not doing a huge amount. But phosphorus, generally, phosphorus concentrations increase across conventional bioretention system, whereas we see significant reductions for the storm filters and the Filterra bios of the world. And similar for orthophosphorus, dissolved phosphorus. So again, typically increased ortho P concentrations for conventional bio, and we just don't see that for storm filter cartridges in this data set. So a couple of comments on that. So assets that only target solids removal. So if it's like sedimentation, filtration, like whether it's a GPT or whatever, or like a galley pit basket, yeah, it's likely to have dissolved nutrient removal for sure. If it's just physical treatment, yeah, you're not going to get a huge amount in the way of dissolved nutrient removal. But certainly the conventional bioretention systems, the studies around those guys show the performance is highly variable, whereas the studies of storm filter jellyfish and Filterra show, yeah, consistently high nutrient removal. So this claim that bio and wetlands are much better at removing nutrients, the data shows the total opposite. Again, happy to be disagreed with. So that's our content for today. I know I've charged through it. There's a lot of content there. We're going to take questions from the attendees, and I can see we've got something like 250 dialing in, so welcome. I'm going to turn this off in a sec, but just a reminder, if you do have any questions, please put them in the Q&A panel. The slides and the recording will be made available at that website. And I'm just going to stop sharing my screen so I can actually see the questions from the audience. So and I can see there's a bunch already come through, but just a reminder, folks, if you do have any questions you'd like to ask Peter or myself,
We'll do our best to answer them.
Now is your opportunity. So Eveline Setiono, apologies, I'm going to mispronounce that.
Forgive you for pronunciations in advance.
One for you, Peter. Can we install jellyfish in suspended form, i.e. not in ground or underground?
Yes, you can. We have done this before within basements of high-rise buildings, which are not in ground. The key thing to remember is, however, that we need access to the top of the jellyfish systems for ongoing maintenance. So if you've just got one standing to the side of a building or something like that, we need to be able to get on top of that system to maintain it. So it's probably a little bit more of a detailed conversation needs to be had on how we would perform the maintenance ongoing, because our personnel would have to get into the system and remove the cartridges from time to time to maintain them.
Yeah. Cool. Question from Jack Raymond. Jack asks, in the replacement of the cartridges, such as storm filter, does the false floor with the drainage pipes in them need to be replaced? Or do new replacement cartridges connect to the false floor system?
All right, so with the way that the false floor works for the storm filter cartridges, basically we have a connector that pokes through the top of the false floor that connects to the underdrain pipework that's encased in that false floor. There's a half bayonet screw attachment that fixes the cartridges onto that connector. When we replace the cartridges, we unscrew it, take them out, put the new ones in, and lock it back into the underdrain. So in answering the question, no, the false floor should last in perpetuity. The other advantage is if you ever happen to get anything blocking the underdrain pipework, we can always back flush it to the downstream side of the weir wall at the back end of the system to clean out those underdrain pipes.
Cool. And just to clarify, so when Peter's talking about false floor, he's talking about this thing. There's underdrainage or an underdrainage manifold in that false floor. So yeah, that doesn't need to be replaced.
No.
What we're pulling out or replacing is the cartridge here.
And the media inside.
And again, everything is reused. The filter media is obviously contaminated, so we can't use that. And we use new filter media, but every other component is actually reused
refurbished and reused, and yeah, goes to another project.
Cool, great question though, Jack. Question from Theo Risley. Theo asks, can you please provide an estimated timescale for the regular maintenance and also the replacement of the products shown today? It was shown for the jellyfish, but I might have just missed it for the other products.
Okay, for the ocean guards, depending on the site, you might need to replace the bags, just the 200 micron bag inside the ocean guards, maybe every 12 to 3 years, depending if they've got holes or burns or anything like that. In regards to the storm filter cartridges, we normally estimate that the media needs replacing every 1 to 3 years. It really depends on what type of site you have and I guess how dirty the runoff is. There is no set rule that every industrial site produces X amount of pollution on in every single case. Same with residential sites, but we estimate 1 to 3 years for replacement of the storm filter media. In a standard maintenance contract, we'd normally include replacement of the media inside the storm filter cartridges every 1 to 3 years and allow for it to happen every 2. For the jellyfish, I'll mention it again, usually 2 to 5 years is when we need to replace those tentacles. For the other maintenance interventions, such as inspections and the rinsing of the jellyfish cartridges, rinsing for the jellyfish is every 6 to 12 months, typically, depending on the site again. And inspections, we normally inspect the storm filter systems at a minimum of once every year when we're on site, typically doing the OceanGuard maintenances and different things like that. If you want any more information about that, all of the operations and maintenance manuals are available on our website, and it does have all those frequencies included in those documents.
Thank you, Peter. Winston Boone asks, as a hypothetical scenario, let's say we go with Filterra for a development and council conditions come back with an item that requires a detailed life cycle costing of the system to be provided. Can Ocean Protect provide life cycle costings of the stormwater quality treatment system? Let's say for the Filterra. I can answer that, Peter, and you can chime in after me. But long story short, yeah, we pretty much do that every day. So it's often a council condition that, we do provide life cycle cost estimates for the proposed solution. And we have costs for all our assets. So assuming that Ocean Protect would be the ones doing the maintenance, and again, as I indicated, it doesn't need to necessarily, particularly for Filterra bioretention. The maintenance can be readily done by others. You talk about maintenance interventions. It's pretty simple. It's the filter media should never need to be replaced. We do recommend replacing the mulch every year or so, but that mulch can be, it's a certain specification that we recommend, a double shredded hardwood mulch, but you can get that from others.
Readily available.
So I hope that answers your question, Winston. But long story short,
I'll chime in quickly,
Yeah.
Brad. But look, in a lot of cases, I get asked this question very often. Even at the stage, if I happen to be doing a music model the size a treatment system for someone who's attending today, if you want me to give a maintenance estimate, I'm happy to do that. One key thing that I always mention is just check what's the inclusions and exclusions of different maintenance providers and what they include and don't include when they are providing maintenance costs. Typically, for a standard jellyfish or storm filter system, I'd give a 10-year maintenance cost and break it down to a yearly figure.
Yeah, good point, actually. Yeah, we did a technical memo around how to review maintenance contracts a year or two ago. And if anyone wants to ask for it, just email me. I'll send it to you. It includes a whole bunch of tips and tricks around, because there's certain maintenance contract providers that they probably aren't. They're probably leaving a few things out that really should be included. Cool. Question from Aping Wen asks, which suits a car park treatment more, jellyfish or storm filters? Peter?
Look, it's really case by case. If you've got a car park site that does not require any detention, say for example, and you sent the project to me to have a look at, I would consider both the jellyfish or the storm filter as an option, and I would probably get back to you with both options if the pricing was similar and the maintenance was similar costs. But if you've got a detention requirement for your car park site, typically we always go with the storm filters because it's more cost effective to locate those storm filter cartridges within a weir inside your larger detention tank. So you've got your stormwater treatment or your quality and your quantity in the one sort of excavation. That saves money for the contractors as well and the end user.
Cool. Another question from Adigvijay Desai. Coolest name so far, and I probably mispronounced it. But Peter, they have asked a question: can the storm filter cartridges be placed in a location that can be flooded during major events? PMF.
Short answer is yeah, you can. basically because they sit below ground. If you had a flood event and the water level builds up to above the top of the chamber, I would always recommend after one of those major events that the units are inspected to see what state they are in and whether maintenance is required. But yeah, there's no reason why you can't use them. Major flood events, I guess, are rare. They seem to be happening a little bit more than what they used to, but anyway, yeah. So yes, is the short answer.
Cool. Question from Siddharth Herath. They ask, how do you dispose of the polluted water? Do you recycle the media? I can have a crack at that, Peter, and you can chime
Yep.
in. So the polluted water, like, yeah, none of the assets we've presented have any sort of standing water. So there shouldn't be any sort of polluted water hanging around.
There will be
But
some in the sump of the jellyfish systems.
oh, sorry, jellyfish. Yeah, you're right.
Yep,
Sorry. Yes. Yep.
that's normally sucked out, and it goes into the the eduction truck, and that will get disposed of as per regulations.
Yep.
But for the storm filter systems, you shouldn't have any standing water in them unless they have been neglected for a long period of time and the water is no longer filtering through the cartridges. But yes, again, that'll be basically sucked up in the vacuum truck and taken for waste disposal.
That's correct. And Siddharth also asks, do we recycle the filter media for the storm filter?
We do, or we were doing that for some storm filter jobs down in New South Wales because they had a recycling contractor that would recycle the media. We're yet to find one in Queensland, unfortunately. But yes, you can recycle the media, but a lot of times it's disposed of.
Yeah, like as we're sort of shown in the photos, it can be quite contaminated, so it is difficult. But having said that, watch this space. We're looking to innovate some cool things in the future, including something around this. Question from Xuri, X-U-R-E-Y. I'll say Xuri. Fan. They ask, where can I find the parameters of pollutant removal efficiency for different devices? I can answer this, Peter, and chime in if, but long story short, you can just ask Peter or me. You can also, and that probably might be your best option because all of our devices, so OceanGuard, StormFilter, Jellyfish, and Filterra, and OceanSave, we've basically got on our website, we've got under each of those product pages, we've got a review paper. And that review paper includes a table of different approval efficiencies. Recognize that every councils often have different, I guess, rules or protocols around assessing proprietary devices. So some councils have come up with different determinations. Also, more recently, the StormFilter, OceanGuard, and Jellyfish have got SQUID approval, as Peter referred to. So those pollutant removal efficiencies are on the Stormwater Australia website. Again, we can send you the link to that if you just email us.
Happy to send the verification.
It can get complicated very quickly. So, and obviously we can provide the music nodes and all that sort of stuff as well. Speaking of music, I know, the next question, a question from Irem Junie. They ask, do you have any restraints to provide free music modeling for jobs, i.e. project size, type, location, etc.?
No.
No. No. And look, we provide the full music model, so you can play around with it or give it to council or whatever. I'm yet to see a job where we say we're not going to do the modeling. Peter, you've done it longer than I have. No.
No.
You heard it here first.
I don't like saying no.
Do it all. Question from Winston Boone. Can a Filterra be optimized as a bioretention swale? We certainly have had them. We don't want water generally conveying across the surface of the filter media because we want it to be ponding and then draining down like any bioretention, but we certainly can integrate them as like sort of linear trenches. Might be best to email me, Winston. I'll send you a whole bunch of case studies. We've done over 100 Filterra bioretention systems over the last few years, and they're all shapes and sizes, and there's some very large ones to be built in the next few months, so watch this space as well. Question from Theo Risley. In a coastal situation where the system will receive significant salt from sea spray, do you envisage any increased maintenance requirements? Great question.
That's a good question. Bit of a different one. In short, not really. The thing I would probably be or mindful of is what we use within the system. Say, for example, if you're looking at a storm filter cartridge system, there's no metal components in the storm filter cartridge, so it's probably more suited for that kind of application because you're not going to get issues with metal and salt water or salt and sea spray. You'd probably need to consider also any aluminium weirs or different things like that might need to be marine grade. But yeah, I don't see any major issues unless you're talking about constant backflow or something like that coming into the system, where if you did have that, you can have barnacles growing in the under drains and different things like that. So just keep that in mind. It's always important to think about where the outlet of our systems are and how they relate to the downstream outlet and what it's discharging to. So just keep it in mind. But look, if you've got any questions, happy to look at it on a case-by-case basis.
And if you have any further questions that you didn't get to today, please just email them, reach out to Peter and I. We love talking about stormwater treatment. So, and just a thank you to everyone who's dialed in today. It's much appreciated. Another super popular session. If you're keen, just a reminder, where have I got it? We've got 4 more webinars in the series, the Stormwater Fundamental series. So if you haven't already registered, please do so via the website link below. But again, feel free to reach out to Peter and I if you've got any further questions. But thanks very much for your time. Thank you to my esteemed colleague, Peter, for giving up his time to share some pearls of wisdom today.
No worries. Pleasure.
Enjoy the rest of your day, folks.
Thanks, everyone.